Welcome, class. To our today we will look at Provide Financial and Business Performance Information Textbook, Chapter 4, Business Mathematics. Um, we'll in particular look at the following topics, starting with simple interest, borrowing money at simple interest, bills of exchange, which is another application of simple interest. Then we'll look at compound interest. Which is more like a usual way of how we calculate interest, a more practical way. And then we look at investment options. We solve the problem of I, interest and period of N. We calculate effective interest rate, and we'll look at annuities as well. Simple interest by formula, basically what we're saying is the investment grows each period at the interest earned on the original amount, original principal. Since the interest is paid only on the original investment, the amount of interest paid each period does not vary. So if you have $100 here, you invest at a 10% for 3 years, so every year you will get $10, which is 10% of the $10 for 3 years. Rearranging the formula, you will be able to get the principal as well. This slide is really just looking at a application of the formula, and here you divided by number of year three. This will tell you the simple interest repayment per year, which is $43 and $33. We are accountant, and therefore this page is showing you a vertical way of, we look at things vertical and horizontal. And this is a way to tell you vertically, we'll say, the first year we have investment of $100, end of the year we earn $10, second end of the year we earn another $10, third year and earn another $10, and hence we have $130 in a bank account at the end of the day. And here, it's just again repeating the same thing. Your total interest is $30. Your principal is $100, and so therefore your total amount in the future time is $130. Another example for you, for 8% per year growth, you have a future value of $1,740. Invest in 2 years. What would the principal be? It's $1,500. Applying applying the formula. Now, let's look at again rearranging the formula. We'll look at the percentages. So 4 years investment principal of $1,000, $300 interest rate. What is your $300 interest payment at the end of $300 interest payment at the end of the period? So what is the interest rate? $300 divided by principal times period, which is 7.5. This the bottom one is technically a similar concept. Just explain to you, if you have, because it's simple interest. Now you have $300 over 4 years, so every year you receive $75, right? For $75 over the principal of $1,000, your effective interest rate is 7.5%. Okay, but I think applying the formula is a much easier go and definitely right method. Again, similarly, now we use the formula to figure out the time period. You have the future value of $2,600, principal of $2,000 divided by $2,000 times 6% of interest. That will give you a 5 years of period. Okay, this is the borrowing amount. Remember, we look at $130. You pay 3 years, and that's $43.33 a year. So this is an example, another example with a principal of $10,000 for 2 years at a rate of 10%. We're going to pay quarterly, so every quarterly you need to pay $1,500. The reason that it's 8 is because it's quarterly payment. So you have a total of 4 payment a year for 2 years. So therefore, there's 8 period of payment. So each period of payment is $1,500. And then we'll look at the bills of exchange. What's the bills of exchange? We looked at that from a way of obtaining working capital, right? So bills of exchange or promissory notes are used by business and government as a form of short-term loan contract, short-term, right? At the end of the period, which we call the date of maturity, we need to pay back the principal together with interest accrued during that period. In the next couple of slides, we're going to calculate the amount payable at maturity, which is the reason that it goes right after simple interest is because it's the same concept we're using calculating involving simple interest. And generally, it's a shorter term as well, say half a year or 3 months as a payment period, as borrowing term because it's a shorter borrowing term. So here we have an amount must be paid maturity $10,000 promissory note. The period is only 180 days. Annual interest rate of 12%. So what we do is, at maturity, what you need to pay is your face value plus the interest. Your principal is, $10,000 face value, what it called, and then your interest rate is 12%. And we are only doing half a year, so 180 days time divided by 365 days, and therefore your maturity value to be paid is $10,591 $78. That's relatively simple. Now, the next topic we'll look at is compound interest, and this is more reality of what you will see in real life. Compound interest differs from the simple interest in the way that the interest is paid on the total value of the investment. So it is paid on the original investment on interest previously accrued. So the interest earned will increase each period as the value of the investment increase. So for example, you have a principal of $10. In the first year, you earn $1 interest, and then on the second year, your principal becomes $11, and on that you earned another 10% interest. Okay, the compounding factor could actually be quite extensive, substantial by the end of the period. Compound interest. Future value formula under the compound interest. At the end of period one, it's as I said, $10 plus one and 1 10 cents. And the next time is this sort of the end of period face value becomes the principal, and then you on top of that you have an interest, and on the third period on top of fees you have another set of interest. So to simplify it, your interest rate will be calculated at principal plus times 1 plus interest to the power of n. N is the number of compounding interest periods. So for example, we have $500 invested in 4 years for 10% compound annually. Let's draw up a table to show how the interest grow over the 4 years period. Find the value of the at the end of the 4 years term using the formula, and find the value at the end of the 4 years term using Excel. So this is principally how we do it. So $500, $50, $550 with the 55. So now we have 55. Then the next period. So the principal at the end will become the principal at the start, and you have the 10% on top, and then you have the principal at the end will become the principal at the start, and then you have another interest rate on top. Yeah, and then at the end you will need to pay $732.05. Okay, so by formula this is it. We don't really need to use the Excel spreadsheet. We won't go through the Excel calculation for now, because what we'll do is at the time when we do practice assessment 8, I'll go through with you all the necessary Excel calculation. Okay. But if you're interested, you can always go and use it and follow this method and try it on the Excel spreadsheet as well. Reality is, I must say that we hardly use this formula um, in reality, because to the power of whatever is easier, and you can use a special calculator for this as well. We really hardly use this formula, okay, in Excel spreadsheet. This is probably more of what we'll do. We'll have the rate, we'll have the interest defined, and we do. But again, we hardly use this formula to do um, a compounded interest calculation. But the way it's set out is in interesting for you, right? So it talks, you will lay out all your parameter before you use the formula. So this is again using the formula. I suggest we use the calculation, which is, to the power of, which we use 500 face value, 1.1 interest rate to the power of the period. It's much better that way. We'll jump through this. Okay. Let's look at interest compounding for more than once per annum. Okay, so sometimes you have interest every quarterly or every half a year, you will compound it. Okay, so how do we calculate that? Interest is usually expressed as an annual rate, but there is usually more than one compounding period per year. Um, Now, when M is the number of compound periods per year, I will be equals to um, annual percentage rate, which is 10%, for example, in this formula. So 10% per annum divided by N, um, which is how many times you pay during the year. And we define N by the number of years times your number of periods during that year. Okay, so therefore, if the annual percentage rate is 10% and the term is 5 years, you compounding 4 times, which is every quarter of the year, your interest will be I equals to it should be equal here, your annual interest rate divided by 4. Okay, and your annual interest rate here is 10% divided by 4, that's 2.5%. So every quarter you have 2.5% to compound on. And then N, which is equals to your number of years times N times M, which is a period, which is 5 years times 4 times per year, that's 20. Okay, and therefore, if you compute the future value of a single sum invested of 1500, 9% for 1 year will interest are compounded monthly. So it's 12 times a year. Okay, so it's 9% divided by 12 is your interest rate per year per times. Okay, and the number of period for 1 year will be 12 because you have 1 year times 12 times of compounding year. Yeah, so that's 12. Your principal present value is $1,500. Using the formula is $1,500 times 1.75%, 0.75%, which is 1.0075 to the power of 12. Okay. Now go back to the formula here. Does it make sense to you? Which is, I think we just have to go back to the formula here that it is the future value is your present value times 1 plus the interest rate to the power of number of periods. Okay? Okay. So therefore, rearranging the formula, we know that the present value will equals to be the future value divided by 1 plus interest rate to the n to the power of n. So using in a question, if you have 10% per annum, 4 years investment accumulated for future value of 2196.15, your formula will put 2196.15 divided by 1.1 to the power of 4, which is 1500. There's another way to express this, which is 9% for 4 period. So if Sue invested a sum of money for 4 years, 9% per annum, and today Sue's investment is $705 for 79 cents. How much did she invest? So we know that we know the future value, we know the number of period, we know the percentage per annum, and so therefore we'll be able to have the present value of 499.99. So this is really $705.79 divided by 1 plus 9% to the power of 4. Okay, and that is equal to 0.7084. Again, this is the Excel way to do it. We hardly in practice use formula like this, like such, because it's easier for us to just use the formula, but understanding the principle. Now let's look at the investment option. Okay, if you are given a choice between two investment options, the easiest way to choose between them is to find the present value of each, compare them. Okay, so you have chosen between you have to choose between 5,000 now or 7,000 in 4 years. So you have to basically you have to compare apple to apple. So 7,000 in 4 years, if the investment can earn 8% per annum and payable quarterly, what choice would you use? So therefore, you would want to look at what is the present value for $7,000 in 4 years quarterly at 8%. How do we do that? Let's look at the next page. You have the answer. So in which case, what we'll do is we have the first option of $5,000 right now, or in 4 years' time, pay quarterly. So your number of years is 4. Your interest per quarter is 2%, which is the I. The number of period of compounding is 4 times 4, 4 years times every quarter. So that's 16 period. And therefore your present value is $7,000 times 1.0. I think it should be divided time divided by 1.02 times 16 period, and the answer for that is 5,099.12, and so therefore you would choose option 2. Now let me just have to say this again. This is wrong. So there's a typo in the slide here. It should be 7,000 divided. It should be $7,000 divided by 1.02 to the power of 16, or 7,000 times 1.02 to the power of negative 16. So there should be a divided. There should be a divided here. Okay, so there's something's wrong with the slides. Okay, so next page. But the answer would be your present value is $5,099 today. So apple to apple, you would choose option 2. Rearranging the formula, we can solve for I and solve for N. Now, effective interest rate. Effective interest rate is generally expressed as an annual rate. So basically, it's if you have different interest rate given to you, so annually, what does that mean? It is an annual rate which could be equivalent to the nominal rate of compounded interest period. Okay. And in fact, for example, an investment earned 10% per annum paid quarterly. So what should actually be the effective? So how many interest period is there, and what should be the interest annual interest effective annual interest rate? So basically, what it's saying that it's 10% per annum, but it's paid quarterly. So in fact, it's actually higher than 10%, right? Imagine that you have a compound 4 times already by the end of the year. So your number of period is 4 times a year. Your effective interest rate is equal to 1 plus your annual interest rate divided by number of period times divided by m times your compounding period. So to express it into and so here you have -1 so that we can express that into a percentage. It's 10.38%. The key is for you to see that, given that you have compounded, 4 times a year, your actual annual interest rate, your effective annual interest rate is higher than what you've provided as a 10% per annum interest rate. Okay, that's the way to use Excel spreadsheet. I'll leave you to explore yourself. Then again, we hardly use this. We just, as you can imagine, given the formula is actually relatively simple, we just use the formula instead of using Excel spreadsheet in reality. Annuity. An annuity is a series of payments or receipts of a fixed amount for a specific number of periods. Payments are made at fixed intervals. In an ordinary annuity, the first payment is made at the end of the first period. So that's something called ordinary annuity, which is the more normal way that your interest payment is made at the end of the period. By formula, future value of annuity is by a value of repayment times 1 plus interest to the power of number of periods to be compounded minus 1 divided by I. And you have open book, and we want to mimic work environment, and so therefore in the exam you have open book as well. If you're tested, you have Excel spreadsheet to do all this calculation as well. So don't worry too much. It looks like a giant, but it's not too hard. Once you understand the formula, you should be able to plug it in accordingly. So growth or annuity, future value. So let's look at an example here. Future value of a series of payment. If you deposit $100 into a bank account at the end of each month, so annuity, 100, 100, 100, 100, 100. How much will be in the account at the end of 1 year if it is earning annuity nominal interest of 12% paid monthly? That is 1% per month. Instead of using Excel spreadsheet, let's use formula. So end of period 1 is month 1 is 100. First 100 will earn an interest of 1 month, and another 100 will be then deposited. So by looking at the formula, we'll have A is equal to $100. So $100 times 1 plus 0.1 plus 1% times to the power of 12 period minus 1 divided by I, which is 1%. Okay, now where do we come up with the 1% again? It's because we have 10% per annum and we are going to pay 10% per annum. We're going to pay on a monthly, 12% per annum, and we're going to pay monthly. So it's 12% divided by 12, so it's 1%. Okay, so by formula, this is what's the answer. So There's also something called a future value table that can be used as well, which let me see if I can find the table to show you um, later. Okay, so what I've done is I have opened your paper textbook, and then I searched for future value table where you can actually see the table here. So you will see if the period is 12%, sorry, if the end of period is 12 and the percentage is 1% um, per period, and then your interest rate, your single sum future value interest rate will be 1.1268. Sorry, it's really hard to see. You have to tilt your head. I'm not exactly sure how I can, make it easier for you to see, but 1.1268. Now, however, given we are looking at future value of annuity, instead of a future table of a single sum, so you will see that in the future table here, you have a single sum, which is, what you have a principal, a principal of summation of a single sum principal at the very beginning of the investment. That's 1.1268. But if you do an annuity, you need to refer to the future value of annuity table. And for a period of 12 period at 1%, your number, the relevant factor should be 12.6825. 12.6825, and that is what you will see in your slides here, 12.6825. Let me show you. Using the future value annuity table, which I just showed you, you will have $100 times 12.6825, and therefore you have the answer of 1268.25. So in reality, we do look at the future table a lot. If you progress to your university studies, that's pretty much what we'll do in one of those finance units. Now, how to be rearranging the formula? We can do the present value calculation of annuity. A deferred, and then there's another concept called deferred annuity. A deferred annuity is one where the payments start a given number of periods in the future. So your annuity won't start until later, basically, not annuity. Annuity starts after a while. So what is the present value of a 5,000 to be received at the end of each year for 4 years, with the first payment to be received in 1 year from today? Assume an annual interest rate of 5%. So in here, the slides actually show you using a formula. But what I can then show you an alternative way is to use the formula here. So to calculate this annuity, you have 2 steps because it's deferred annuity by 1 year. So you first calculate the amount of value of annuity at the start of the term, which is 1 year behind the period anyway. So here you use the formula present value of annuity. You have 5,000 annuity payment times 1 minus 1 plus 0.05, 1 plus 0.05, which is 1.05 because you have 5% interest, to the power of negative 4. You have 4 years period divided by 0.05, and that will give you the amount of 17729.75. And then we have to, because it's 1 year deferral, so we have to then calculate another present value for 1 year, and it will be 16. So you will use this amount divided by 1.05 to the power of 1, and that will give you 16885.48. So now I just prepare a little a bar graph to show you the concept of annuity. So for the ordinary annuity, you will have a payment on each end of the period, say 1, 2, 3, 4, 5. So you have, say, $100 in here, followed by $100 in here, followed by $100 in here, followed by $100 in here, right? Followed by $100 in here. So after 4 years, you will, the first year, first year, second year, third year, fourth year, after 4 payment, all you need to do is a calculation of a present value all the way back to time 0. Okay. But for deferred annuity, what we are saying is your first money deposit won't go from here. It will go from first year. It's the 1 year after your first year. So consider then that become your first payment, second payment, third payment, and fourth payment. Yeah. So therefore, your first step is to have your annuity first calculated from step 1, which is from here to here. Right, and then we have to calculate another one from here to here. I probably should use 1, 2, 3, 4, 5 instead. So let me start over. Let me erase this. Sorry guys. Just try my best to. So this is 1, 2, 3, 4. So that's easier for you if I go, this is period 1, 2, 3, 4, 5. Let's erase this. So basically what we're saying here is you won't have your first payment until your second period. So you have the first payment here, second payment here, third payment here, fourth payment here. But in reality, this is already the 5th year. So your step 1 is to first calculate the present value using the formula to year 1, and then you discount a further year to today. So you can actually have the present value for today. Okay, so let's move on to the next concept, annuities perpetuities. This is interesting. Basically, we're saying that we'll pay you perpetually until the end of the day. Even that's the case, it's the easiest formula. Even that's the case, you will be able to get a, so it doesn't matter anymore because it's perpetual. And the formula is really easy, which is annuity divided your annual payment divided by your rate. That's in this case, scholarship paying 25,000 a year in perpetuity with the first payment in a year from now. So his money earned 5%, so that will be 25,000 divided by 0.05 equals to 500,000. So that's basically telling you I'm giving you $500,000 right now, present value of that, but you're receiving it 25,000 each year until the end of the day, perpetual. So that's it for today's class on context of Chapter 4 Business Mathematics. Again, your focus will be sort of understand how the formula work. It will be open book assessment, and you'll be able to assess this formula during the exam, and this is relevant to, I think, assessment 8, for which your practice assessment for assessment 8 will be the most important, very important for you to know how to apply this formula. It will help you to learn how to apply this formula to get the answers. So that's it for today. Thank you for your attention.